So welcome back. We just had a quick look at our price data that we want to work with, and we see there's some really strange thing going on here for the daily adjusted close price at SAP. That just looks awkward. So let's just work with that. From SciPy, import stats. What I want to do is okay, maybe I should have an extra cell first. Let's just translate prices to returns and then plot the Z scores. Or before we even do that, let's just see. PD from sap.de. There's a panda, so I think that should work. Standard deviation 30. Now we got the NumPy. Guys, listen, that is daily data, so let's annualize that. Never do that with price data. All right, I tricked you. So therefore, we first work with return data. Let's just get the returns first. Now we will take log returns, right? Prices are non-stationary. So we are going to work with returns. What do? Let's give me a little daily return panel. Okay, so we take the NumPy. NumPy has a log, and we say PD divided by PD.shift, right? These will be daily returns. And that's what we have. The first entry, the first row will be a none. Therefore, we say RD equals RD.drop NA. There we go. And let's look at the first two rows. Take that. Okay, that looks good. 42 firms, daily returns. Okay, great. Now we take the SciPy, import stats, and I wanna get at the Z-score. I wanna get at the Z-score. So let's just do that. We have already matplotlib in the package. Here. Okay, great. So we take and that I have. Okay, great. So let's just do some plotting. plt.plot. I want rd.index. I want the time period, and I want the z-score of SAP. So which means I take the stats package dot z-score, and I just read in the SAP DB. Why not have a nice title? And the title is Z-score RDR SAP. All right, that should work. Look at that. Right, we got here the COVID. Might also be 5 or 6 standard deviations, financial crisis here. But look at that. That looks completely awkward. That looks completely awkward to me. Completely awkward. And when you do some, I mean, I don't know, SAP return 2001, I think this was when at the end of the year, so let's say October. I don't know, I mean, SAP. Corporate events. 2001, right? I mean, a 20 standard deviation event cannot come unnoticed. So what's here? SAP 2001 firm ongoing growth. I don't know. That doesn't look like what my price looks like here. So here's what I do. Let me just plot let me write a function that plots the z-score for all firms, but not just the z-score, but the z-score above a given threshold, let's say 10. right? I want to have the 10 standard deviation events and more, because these are events which either they got a lot of economic information or maybe it's a data error. So let's just get a feeling for that data. And so let's just write a function, print the Z, and the input will be the return panel. It's the threshold for the standard deviation event. And let's have a little p to give me a little pause. All right, so the Z will be stats.zscore of R. Now I got the Z score. And I also need the tickers, just to have a nice picture. And I use the same A from above, so I use my aggregate, no, not my, the ag function. The mean is just some stuff which I exploit. So now I take the transpose and then I take the index out of it. So now I have a column with tickers. That's what I need. And now give me a little counter equals 0. Awesome. So let's have a loop. For I in tickers, what do you do? First print the I, okay? First print the I. I want to see which ticker are we working with. Next thing I want, give me r.index. That's the x-axis, that's the time. And for the y, give me the z. The z is known from above, and therefore give me just all the z's you have for a specific ticker. And your ticker in terms of the counter, which starts in 0, and I update that at the end of the loop. All right. And what I now do, I now embed a filter. So I say filter is numpy, which I loaded the package, take the apps of y and larger than d. So the filter will be all of the z-scores which are above a threshold d in absolute values. All right. And then I want make a plot. Plot scatter of. Plot the x, but not the full datetime, just the filtered one. And the y filter. Yeah, just give me the ones which look awkward. Just pause for a little bit and just increase the counter by 1. Would you mind doing that? No, I wouldn't. Awesome. No mistakes so far. So let's just visualize 10 standard deviation events. Print, call the function, which is print z of. Give me the RD. I take a 10 standard deviation as the threshold. And for the P, let's make it fast. Just give it 1 second. And now we see which stocks had a 10 standard deviation event on a day and when. Adidas, no such thing, no such thing. 1 10 standard deviation event, no such thing. We went with C, no such thing, no such thing. BASF, no such thing. Bayer, 16 here and here. Plus 12. BMW, no such thing. BNP Paribas, no such thing. Interesting, not during a financial crisis. Daimler, 11 standard deviation event. That was plus 11. COVID. All right. Fresenius, look at that. 10, minus 20, minus 30. Is that Gaussian? Most likely not, right? We shouldn't see more than 3 standard deviation events for a Gaussian. And here we have 10, minus 20, minus 30. So we got excess kurtosis here for sure. Do we have skewness? Sure. Which direction? To the left. All right. ING, 2008 financial crisis, a minus 11 standard deviation event. These firms I don't know. Minus 10, Nokia, 2013, plus 10, all right. Here the x-axis is not so nice, don't see what that is, minus 16, minus 11. So you see roughly half of all firms have these outliers, but look at that. Minus 21, roughly plus 21. Well, what's that? Which one is first? I don't know. Let's say plus 20, minus 20. Plus 20, minus 20. Plus 20, minus 20. Plus 20, minus 20. Are you kidding me? That can't be. I don't know. I mean, not seeing any type of information just from the quick search on the Jahresbericht. That looks very predictable, isn't it? It's not just that it iterates signs, but the magnitudes just match perfectly the way it looks. Boom, 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 boom. I don't buy that. Siemens, 20 minus 20. That looks very suspicious to me as well. That's also interesting in itself. Boom, boom, twice. Minus 11 standard deviation at standard deviation events. Would be interesting to see what was going on there. Is that COVID 2020? Yeah, might be. Look at Vivendi, minus 11, minus 11, minus 12, minus 13. Wow, that was hit by really negative skewness. Volkswagen, 34. That's a short squeeze, 2008. That's a fundamental thing. But SAP, give me a break here. Let me know. I mean, for the moment, I summarize. These are adjusted returns from adjusted prices, meaning they are adjusted for dividend splits and for dividend payouts for splits. So it should be only driven by fundamental information, right? I don't buy it that there's some stuff going on here which looks like that. I just don't get it. I think it's a data error. All right, so for now, prove me wrong. I want to learn. I just think that is a data error in the Yahoo Data Finance database. That's what it is. So what do we do? Well, I don't know. We have to correct the data first. Yeah, I think let's just stop the video. Let's do some thinking here. I just can't believe it. Yeah, let's say it that way.